walk through the key to part one and talk about the various ways you approached it. So you kind of have to decide when I'm walking through this what you did, and then I'm going to help you kind of identify if you didn't already understand what you came up with, what it stands for. So here's the big deal. We had some data that we collected from you guys in class, and we came up with a percentage of people that would buy it at a certain price based on that data. So we polled you, how many of you would be willing to pay $12.50 for a shirt? How many would be willing to pay $15 for a shirt? How many willing to pay $22.50? And so on. And then we also got some information about adults/parents from some of you as well. What we did then is said, hey, the percentage of people willing to buy at those prices, that was a nice thing to find. So a percentage out of 70 total. Okay, so that's where I got that from. And then multiplied that by 25,000 over here to get a total saying, hey, 25,000 people show up to relays, which is kind of a general number on a given day. How many shirts would we sell? So that's where we got this from. We did regression models, and there's two ways you could have done this. Depending on what you decided was your X variable when you did your regression, you got these different regressions, and I'm going to choose the linear. So what you guys did is you did a linear, you did a quadratic, and you did a natural log. I'm going to steal linear as my example. I'm going to walk through everything with linear and just say, when you do part two, you can't use linear, so you have to use one of the other models. Okay, that'll change it up a little bit for you, and it also it won't make it terribly different. It just removes linear from your arsenal of possibilities. Okay, if you chose X in this fashion that you see over here, your regression looks like the one you have on the right here, and your equation was something similar to the one on the right, where dollars was your X and your Y was the number of units, number of t-shirts sold. If you chose that, here's a model that happened. You have to remember that X is going to always stand for dollars. And so whenever you're finding an X in any of your formulas, it will stand for dollars on this particular sheet. So if I go down here to the next one, the way it's defined is that you may have put in X as this regression as X is the number of units and Y is your price per unit. And it's the same information. It's just realizing, I have to remember every time I see an X, it stands for number of shirts sold. So it's a thinking process, and I'm okay with either one. This changes your revenue formula down below accordingly. And I got these out. If you put X as price paid and you multiply it by your demand function, well, your demand function is spitting out in the first example here where X is the number or the price paid, let's say, then what your demand function was spitting out as an output was the number of shirts sold. So when you multiplied them, it does give you revenue. It's a valid function. If you chose X to be the number of units sold, then your demand function was spitting out a price that people are willing to pay. And when you multiply them, you get a valid revenue function. Both of them are valid. They graph and give you information that's accurate. I like the one on the bottom here. I chose it. I prefer to think of X as the number of units sold. And you may or may not have chosen that, but I think it's a nicer way to think of X as the number of units. And then it's easier to deal with a lot of the other stuff later in the problem. So if I choose that, here's a graph of it. Here's my revenue function, linear, where X is number of units. And when I say in part two, hey, would you maximize revenue, please, and tell me what you get, you can actually graph this and go to the peak here on Desmos. It says 15,000 units, 910 units, is where I get my maximum revenue, and I rake in $278,425. Voila, that's it. The calculus that we've used in the past is we would set the derivative of revenue equal to 0, and it would tell us X equals $15,910. Technology does it all for us, and I'm cool with that. The next piece is I said go get cost, and that was using that spreadsheet from our supplier with 3 colors and having a particular price that goes with it. This is where it got a little crazy. The things that you got are either one of 2 options up here. You probably made these work pretty nicely, and I'm not going to grade them incorrect, but what I did want to do for you is saying if you chose a particular route, so if you chose X as, let's say, the number of units sold, then if you did the regression over here to the right, here's what would have happened. Here's one possible error that would have happened. You have X defined as units sold on the outside. You have this regression you came up with for cost. But here's the deal. Units sold on the outside, and inside you have this function where X is measured in dollars on the inside, and that's a conflict of interest. You're doing X units defined, one as units and the other as money, and that's just mathematically not solid. So we got to move on to another option. Maybe you chose X was price per shirt. Then you take the regression model inside, where now X is price, a dollar amount, and inside the regression model has X as price or a dollar amount kind of thing, and that's an agreement, so that works. It's this picture up here again. It's just using the this in a different context with X being price on the outside of dollars, and inside it's also in dollars. We match the units, but now it's not something we're interested in. Cost is not a matter of multiplying price times price. We need is the number of units. So price times the number of units sold is how we figure out total cost. So again, this doesn't get you anything worthwhile. So if those things happened, that's all right. What would work is if we were to take X as the number of units, and you want to make sure that, and then here on the next function, you take a graph of this one where X is still the number of units, and what you get is an output of a particular price. And so if X is defined as units, and what your regression on the cost graph that we had, all that data, if you did a regression where your output was cost per unit, then you have an accurate function that tells you the maximum cost. And so number of units times cost per unit, which is what this regression model spits out, this is valid. The only problem with this is after about 1,000 units, if you get beyond that, this model starts giving you really, really, really low t-shirt prices that are unreasonable. So that one wasn't particularly reasonable, and that's nothing that you need to worry about, but this was the most valid version of the cost function out there, so I'll highlight it again. So if you came up with that, perfect. If you came up with the others, I know where your thinking came from, but I want you to just take a look at that and say, and get a sense of why that doesn't work mathematically. Okay, so the highlighted one, that's the preferred one. In the end, when you guys are doing the profit function, it's revenue minus cost. To simplify this whole process, to kind of get out of some of the issues that happen with this cost function, we're just going to take our revenue function, and I would take the preferred one up here, where X is the number of units, and the model is the model that goes along where X is the number of units, so we have the X-axis of units. Okay, but down here you take that revenue function minus this number of shirts sold times 1.2 times $2. That's assuming we talk to this company and they're going to sell them to us as a supplier. They're going to supply them for $2 a shirt. And the number of shirts sold is something that we got from maximizing revenue. So when I maximize my revenue, I figured out we're going to sell 15,910 shirts. And when I take that number, 15,910 shirts, which is part of optimizing, times 120. So, and it just depends on if, I'm assuming we're working with this in a fluid fashion, but times 120 is going to give you an extra 20% of shirts just for that size variation, because you know that people aren't going to, you're going to have leftovers. You need some extra supply just to accommodate variation in people's size choices. So number of shirts sold times 1.2 times $2. This will give us cost. It's the price per shirt, $2, times how many we sold with an additional 20%. That is a reasonable profit model that kind of sets the sale of shirts on here as a reasonable amount. So what I did is I went ahead and graphed that profit function so you kind of see a version of it, and I'll show it to you here. Here's our regular revenue function, so this is revenue, just like above, and minus the 1.2 times the number of units X, remember X stands for units sold, times $2. So there's our cost right here. This is that function I was just showing you. And this gives us a pretty reasonable estimate of what our profit should look like. And notice that there's a revenue is more than profit, because revenue, remember, you have to subtract cost, and we're getting something lower. And so you're actually seeing that also what maximizes revenue isn't necessarily the same number of units that maximizes profit. So there is a difference between those two. And that's something where in part 2 it asks you which would you prefer, which is a better one to use as your driver for number of units sold and price. If in part 2 you want to find the price that gives you that amount, you have to go to your demand function to do that. Like 15,910 units or 14,819 units, If you want to know the price that goes with this, you got to go back to your demand curve and say, all right, if I put that particular price, if I have a price of, or a number, I'm sorry, number of units sold of X equals 15,210, there's a price that goes with it, and that's this function right here. If I highlight it, the one that I use for my demand curve, if I put 15,000 in for X right here, it'll tell me the price Y that people are paying for that particular shirt. So when that becomes a question you need to answer, you just got to plug that X number of units back into your demand curve to find the price that goes with it. All right, that's the end of the story.